Let us look into the first case study, which is two sample t-test. Here is the case study. First, let us understand that, and then we'll understand the steps involved. Marketing strategy. There is a financial analyst at a financial institute who wants to evaluate a recent credit card promotion. After the promotion, 450 card holders were randomly selected. Half of them have received an ad promoting a full waiver of interest rate on the purchases which they make over the next 3 months. So over the next 3 months, purchase as much as possible. There would be no interest rate. Okay, that's one ad. Another ad was sent to people, and this ad was a standard Christmas advertisement. Christmas is approaching, and then people have started promoting based on this. Now, the financial analyst wants to understand whether the ad promoting full interest rate waiver, did it actually increase the purchases, yes or no? That's the problem which we have to solve here. So first things first, let us try to understand what is the Y here. Y and what is X here? Y is purchase per customer. How much did you purchase? How much did each person purchase? Only based on that, you will be able to conclude whether your new ad is effective or your standard ad is effective, right? And the X is a type of promotion, right? Type of promotion. And what are the various types of promotions which we have here? One is your ad which was promoting a full waiver of interest rate. Another ad is a standard Christmas advertisement. So there are two advertisements, right? And purchase per customer is your output. If Y is continuous and X is discrete, let me go back. What do you do? And if you're comparing two populations, two things, standard, new, I'm comparing the purchases mean, right? I need to check whether the data are normal or not. That's my first step, right? And the second step is I need to check whether the variances are equal or not. And based on that, I need to select an appropriate test. All right, that's the first step. Is data normal or not? And this is the Minitab navigation which is provided. Then you perform a variance test, either an F test or new test called as bonnet test. You can perform any of those tests. And as part of step 3, you look into two sample t-test. But will it be assuming equal variances or will it be assuming unequal variances? That's the decision that we make based on test 2. All right, so what are we waiting for? Let us open this marketing strategy in Minitab and then try to solve the problem. Here is the marketing strategy problem. I have amount which people have spent using their credit card in dollars, and I have the type of promotion. Is this promotion related to interest rate waiver or is it the standard Christmas promotion? I've done that, stacked it to appear in the two columns. Now let us check whether the data are normal or not. What do? I simply go to Stat, Basic Statistics, Graphical Summary. I select both of these, interest rate waiver and the standard promotion, and click on OK. I get these two values, right? Report for standard promotion and report for interest rate waiver. I get two charts, and those charts are placed here. All right. Even before we continue, you need to first come up with your null and alternate hypothesis for any test which you're performing. Null hypothesis says don't take any action. Data are normal. You need not do anything. Alternate hypothesis says data are not normal. That is what they see. Now we are checking for Anderson-Darling p-value. You have done everything and you're looking into Anderson-Darling p-value. And we know that if p is high, that means if p is greater than 0.05, why am I taking alpha value as 5% or 0.05? Because that is universally acceptable until and unless your management comes to you and says, hey, no, I will not allow 5% chance of making a mistake. Take only 1%. Until and unless someone says that, you go with 5%. 1 minus alpha is the confidence level which is provided here. Hence alpha is 5%. Confidence interval is 1 minus alpha, which is 95%. All right. So here is a p-value. In both of these cases, Anderson-Darling normality test p-value is greater than 0.05. And it is clearly saying that if p is high, null fly. P high, null fly. That means you're going to accept null hypothesis. And what is null hypothesis saying you? It's saying that data are normal. And remember this flowchart, extremely important. You're checking for the normality, and if you conclude that the data are normal, you need to perform the next test, which is are variances equal or not. Move on, move on, move on. So this is the navigation, right? Basic statistics to variances. Here is the null hypothesis and alternate hypothesis. Null hypothesis says both the variances are equal. All is fine. Don't take any action. Alternate hypothesis on the other side says variance A is not equal to variance of B. Now we have to perform this test using Minitab. Go to Stat, Basic Statistics, and to Variances. Let me go to the Minitab and let us do that. All right, where am I? Here. Let me go back to the worksheet by clicking on this. Now we need to check whether the variances are equal or not. You need to go to Stat, Basic Statistics, click on two variances. I clicked on that now, it's coming up. Each sample is in its own column C5 and C6. That is what I've selected. I clicked on this, I selected C5. Oh, my bad. Let me remove that. Okay, let me select this. All right, let me remove this. Let me select the sample 2. And I simply click on OK. All right, I got the result. But if I want to look at the text, I go to the session folder. I click on this, right? There's the same thing which is copied and pasted in our presentation. So we will go to the presentation and understand this bonus test value. Here we go. Presentation mode on. Bonus test p-value is 0.662. What is this Levene's test? If you assume that the data are normal, you go with the bonus test. If you do not assume that the data are normal, you go with the Levene test. We have already proven that the data are normal, right? Then why am I making the statement that you have to assume that the data are normal? And if you assume that the data are normal, you go with the bonus test. Why am I making that statement that I'm assuming? Think about this population and sample. I'm working on the sample, mind you. I have access only to sample, right? So I'm working on the small sample and I found the data are normal. If the data are normal for the sample, then is it normal for the population? You really don't know, right? But you're assuming that the inferences that you make about the sample would be applicable to your population as well. Hence, I'm saying assume. So if you assume that the data are normal, you go with the bonus test p-value. If data are not normal, if that is what you assume, you go with the Levene's test. Anyways, let us look into this p-value. P-value here is 0.662. Is this p-value greater than 0.05? Oh yeah, it is greater than 0.05. P high, null fly. So you accept null hypothesis which says both the variances are equal. And let us go back to the flowchart and see what happens if the variances are equal. If the variances are equal, you're going to perform or compare the means using two sample t-test, assuming equal variances. You're assuming equal variances now. Let me go there. Let me go there. Let me go to the third step. All right, it's there here also. So first step first, you need to write down the null and alternate hypothesis first. So you're saying that you're comparing means using two sample t-test. So you're saying mu of process A is equal to mu of process B. Alternate hypothesis says both are not equal. Mu of A is not equal to mu of B. This is the Minitab navigation which you can perform. All right, let us go back and make the corrections. Or let us do that. Let me make a small correction here. It is 2 sample t-test, by the way. All right, that's a small one. Go back to the worksheet. And how do you navigate? Go to Stat, Basic Statistics. Click on 2 sample t-test. Each sample is in its own column, right? So since I've already performed this exercise, it was showing those values here. Otherwise, values would not be populated, right? All right. So sample 1 is interest rate waiver. That's the first advertisement type. And then we have the standard promotion advertisement type. I click on options here. And don't forget to select this option called assume equal variances. That is what we are doing, right? Here also we are assuming that variances are equal. Why am I saying that we are assuming? We have already proven that, right? That the variances are equal. Why am I saying it's assume? I'm assuming because whatever analysis I'm doing is based on a sample. And then I'm going to draw inferences about the population, right? So simply click on OK and OK. Here we go. This output is copied and pasted here in the presentation. So let us move there. Here it is. You go to this option, select assume equal variance. It's extremely important. And when you click on OK, magic happens using a magic box Minitab, right? And here is a p-value 0.024. Oh, is this p-value greater than 0.05? No, it is less than 0.05. If p is low, null go. That means you're going to reject the null hypothesis. So you're simply going to reject this null hypothesis and say that the mean of the new ad promotion of interest waiver and the amount spent because of the standard Christmas promotion, these both are not the same. That is what you're concluding here, right? That is what you're concluding here. And you might ask me a question, but what if I want to find out which promotion has generated more revenue for me? Yeah, that would be discussed in your Six Sigma Black Belt, right? We will limit ourselves to few things in Six Sigma Green Belt. In Black Belt, we'll look into the entire concept, by the way. All right. This is all about first thing. You might have a few doubts, right? Why do we check whether the data follows normal distribution or not? Now, 2 sample t-test assumes that the data follows normal distribution. It assumes, hence we are performing the normality test because we want to know which test we have to perform, right? So we carried out Anderson-Darling normality test and we found out the p-value. And we know that if the p-value is greater than 0.05, we consider that the data are normal. What is Bonnet test for? Bonnet test is used to compare variances of 2 groups, right? Here it is. Bonnet test results help us determine whether we should assume equal variances or whether we have to perform test by assuming unequal variances. What is 2 sample t-test or 2 independent sample t-test? It compares and tests the means of 2 independent populations, right? 2 independent sample t-tests are of 2 types, and we choose one of them depending on the Bonnet test. We either do this test, which says 2 independent sample t-tests assuming equal variances, or we perform 2 independent sample t-tests assuming unequal variances. Do you still have challenges with hypothesis testing? Do not worry, we still have 3 more case studies left. Things would become extremely clear. Trust me.